Hello everyone and welcome back to Chess Game Design with me. So in the last lesson what we did was fix the pawn and make the rook movement so that they can't go over a piece. Today we're going to be working on the bishop. Well, I guess actually we made the rook move the way he's supposed to. Today we're going to be working on the bishop. So like I did last time, I'm going to copy and paste everything and explain it. I am also going to start the game just so that I can visually demonstrate what I mean by certain movements of a bishop. Let me just set them up really quickly over here. Here we go. So as you can see, currently they aren't going through pieces. And if I need it, I will go back to it. So the bishop, I've programmed the bishop to work very similarly to how the rook works. Or at least with the collision thing. By collision I mean when there's a piece so that it doesn't go through the piece. So first of all, let's ignore those for now. The condition which needs to be met so that a move is valid and is added to valid moves at the start is that the number of rows moved has to be equal to the number of columns moved. In our pseudocode, I believe we did it by dividing them dividing one by the other and then getting the absolute value as being 1. But if you do that, sometimes it's going to occur that you're dividing by 0 and you're just going to get an error if that occurs. So this is why instead of dividing them and comparing them to 1 or -1, I've just made them if they're equal to each other, or if they're equal to negative of the other, because you can have 1 or -1. We could make an absolute value, but for this we don't really, because it's only used once, I don't really see the need for making a function which finds the absolute value of something. So that's how I've done it, and I have an or in between them so that it's that or that. Hopefully that makes sense. So if those conditions are met, then it adds it to valid moves. What that means is any square which is in the bishop's x is going to be added to valid moves, even if it's going through pieces so far. The next thing I do is very similar to the rook. So if you remember, in the rook, after we added things to valid move, we also checked where we need to stop the rook from moving if there is a piece in the way. So with the bishop, if there is a piece in the way, I do the checking very similarly. I call the variables slightly differently. So check up left square, that would be in the up left direction. So up and left, or if you want northwest, then you have up right, northeast, and so on. So up left would be looking at this, up right would be looking at, in our case, nothing for the black bishop, down right would be looking at the pawn, the white pawn over here, and down left would be looking at nothing in our case with the black bishop. So those also get added pretty much similarly to how the rook. However, this time again, we do have the child count doesn't equal 0, i.e. there are pieces in the square. But the comparisons I do with the rook, they were much simpler because it's either the row that changes or the column that changes, and we've already specified it here. However, with the bishop, both of them change at the same rate. So I do that and that. So if the row of the square is less than the row of the piece that I'm currently looking at, i.e. if the square which I'm looking at is below the piece, as well as being to the right of the piece by the column, then check down right square equals j. And everything else works the same. As you can see, just the signs are different and then the variables here. Also, if you remember with the rook, we had something like this, so if it doesn't equal null, then change it. If there's no piece, it is still going to equal null, which is why later on we check for cases of null. So that's how the bishop works. If you don't completely understand it, first of all, do look at what we did last time with the rook, because it works in a very similar logic with the rook. So moving on, then we have the copy of the valid moves list, and over here it might be slightly more complicated, because again we're comparing both the columns and the rows, whereas in the bishop we were comparing only the columns or only the rows. But the comparisons are very similar once again. The first thing we do is check that the square which we're looking at has a piece on it. And if that is of the same color as this, then we remove it, because we don't want to be able to take our own pieces. We did the exact same thing in our rook script. Next thing we check is, well, we check the top two directions. So we check the up directions. We check this direction, with this for each loop. So, as you can see, check up left square doesn't equal null, i.e. it does have something in it, so a piece has been stored in check up left square, or a square, sorry, not a piece, as we have said over here. And if this would come from over here, and if it's not null, similarly with check up right square, if it's not null, we check the other cases. The other cases are basically just a copy of what we have up here, but instead of this we have the check up left square or check up right square instead of the this here, and we just compare it. And if those conditions are met, i.e. there's a piece in the way, and then we need to, if there is a piece in the way, we need to remove everything that's behind that piece, so we do remove. Sorry about the noise from outside, I have no idea what that squeaking noise is, it's kind of annoying. But moving on, hopefully you can't actually hear it that well, it should be fine. Then, again, like we did in the rook, I do make a reverse of valid moves copy. A valid moves copy again has all of the valid moves in it, without the removes, because what we remove from is the valid moves, not the valid moves copy. And again we make two booleans, like we did with the rook. However, we name them different things because we're looking in diagonal directions, so down right and down left we're looking at, so down right and down left in those two directions where my mouse is pointing. And then, again, using a for each loop, similarly to how we did it with the rook. Everything is very similar to the rook. However, instead of doing just horizontal or vertical moves, we do diagonal moves. And again, we do the checks of both the rows and the columns, as you can see. Whereas with the rook, we only did one or the other. And we have if this, else if this, and remove. I could actually, to make it more efficient, if I really wanted to, do this, put an or there, copy and paste this in. That also works, meaning I can just remove the else if statement from there. And so I can do the same in the rook, but I'm not going to do that for now because it doesn't really matter. So if found left, i.e. if that's true, which in the first time we're going through this, it's not going to be true, or found down and the rest is true, then it's going to remove it. Why it's going to remove it? Well, it's because there's a piece in the way, and we're looking in the reverse, so the piece would already have been found. So because we know how it's scanning, similarly with the rook, before the reverse, it's scanning from left to right and from bottom to top. So left to right first and then bottom to top. However, once we reverse it, it's looking at it from right to left and from top to bottom. So we find the found down and found down right and found down left before the collision. And so if there is if that piece needs to stop any further movement, then we just remove it. Very similar to how we did it with the rook. And then we have this, which just changes the color. And so what that all looks like once we run the program is, well, sometimes that happens, it bugs out when you haven't been looking at it. Again, I don't completely understand why that happens. There we go. You can see that the bishop can't go through any of the other pieces. It can't capture your own pieces, but you can capture the opponent's pieces. So it works the way we expect it to. Again, the logic is very similar to the rook. So in the next lesson, what we're going to be doing is working on the queen. The queen is basically just a merge. You just merge both the rook and the bishop and make the queen. It's very easy, to be honest. I didn't have to do much work to get there. And ignore that, that's from us looking here and then back to here. Sometimes that happens. So I think that I'm actually going to end the video here. Thank you so much for watching. If you enjoyed, then please give me a like, share and subscribe. If you have any questions, do feel free to ask in the comments down below. I'll be happy to answer them as soon as possible. However, if you didn't understand something, I would also recommend that you watch my rook video, the previous video in this playlist. Yes, I do have a playlist for this, because I do explain everything I did here in more detail with the rook, because the logic is very similar, as I mentioned like 10 times now, I believe. So, thank you so much for watching, and until next time, goodbye.